I'm Chris Bryant, CCIE number 12933, and welcome to this combination CCNA CCNp certification training video, where today we'll take a look at some OSPF commands and also a closer look at OSPF point-to-point networks. We tend not to pay a lot of attention to this network type because, of course, especially in the CCNA, we're learning all these other network types, especially over frame relay, where there's a lot of extra configuration and other considerations we have to take into account. Where a point-to-point network, we generally don't have to take a lot of things into account, but there's one small little quirk, as there always seems to be, that we need to be aware of for your exams and also for production networks, because it's something I hear regularly about from people who are saying, I've got this adjacency, but I'm not seeing other things I think I should be seeing. So there's your teaser. I promise I'll clear up what I'm talking about there in just a moment. But first, let's take a look at router 3 here. What I've done is created an OSPF adjacency over a point-to-point link between router 3 and router 1 over the 172.12.13.0/30 network. And you can see here that I have used that network command, and we always use a wildcard mask in our network commands with OSPF. And of course we have to specify the area, and I've put it in the backbone area, area 0. I also have EIGRP running, and of course let's keep in mind that with EIGRP that number represents an autonomous system, where here in OSPF this number represents a process number. So the configuration looks similar, but those numbers next to the protocol names don't indicate the same thing. Some other things to watch out for here: when you have two protocols running on the same router, as we do here, they don't automatically know about each other's routes, the protocols that is. So here, if you're running EIGRP and you've got some EIGRP routes in the routing table, the OSPF process is not automatically going to know about them. To make that happen, we have to configure something called route redistribution, which can be a lot of fun or a nightmare depending on whether you have it working correctly. It's definitely something though you'll want to be practicing for your CCNP exams, and I do have some other videos on YouTube and on my website concerning route redistribution and things to look out for. Here though, again, we're just looking at the OSPF configuration, so we're not just going to take my word for it that we have an adjacency. Of course, we're going to verify it just as we would in a production network. And I want to show you first off what the command is not, and then I'll show you what it is. It is not show IP OSPF ADJ or adjacency. It is show IP OSPF neighbor. And the reason I also show you that is that it's easy to get the two mixed up, because there is an important debug called debug IP OSPF ADJ. And that's to debug your adjacencies, of course. And if I run show IP OSPF neighbor and I don't see anything, that's when I would go to my debug first thing. Also remember that caret under the A there, that's going to show you where you went wrong in the command. And we all go wrong sometimes in a command. It happens to everyone. And of course, as we know, and the reason I'm putting that bar all the way out there, not all of our commands are this short. Right? They can go all the way out here, especially if you're dealing with wildcard masks, that kind of thing, and then you hit enter and you get told invalid input. Well, remember that this caret is very helpful in showing you where you went wrong in the command, because it's saying you were fine all the way up to here. So when we run show IP OSPF neighbor, you'll see the neighbor ID there. That is the OSPF RID of the remote router. If you're not familiar with OSPF RIDs, you don't want to watch some of my other videos here, but also that's a topic you need to have down cold before you take your NA and NP exams. The priority is the OSPF priority on the remote router of the interface through which the adjacency is being formed, and we know that that is a default of 1. We also see some values here that we're familiar with, certainly dead time, IP address of the remote router, and interface on the local router through which the adjacency has been formed. Under state, we have the word full, and we know that we like that. That's a full adjacency, but we have a dash there. And that's a little odd, because we're used to seeing one of three things, right? DR, BDR, or DR other. So we're going to come back to this in a few minutes and see if that has changed. Even though we have a full adjacency, you think everything would be where it's supposed to be right now. So let's look at one more important OSPF command, and this is the one you really want to start troubleshooting with once you've identified where a problem may be. So you looked at your neighbor command there with OSPF, and you think, okay, I've got a full adjacency, but why don't I see anything about a DR? Where's my designated router? Well, you can see here we've got area 0, network type point to point. You see the process ID and the RID of the local router. The timer intervals are what we expect them to be, 10 and 40. You know the rules about those, or you definitely need to learn them before you take your exams, and how to change those. And you see the neighbor count, the adjacent with neighbor 1111. So everything looks good here. You know, the adjacency is up, so everything seems to be fine. And we could debug this to death and we would not find out what that dash really means. Except if we run a debug, we would see that there really is no DR-BDR election. Because on an OSPF point-to-point network, we don't have a designated router or a backup designated router. And if you give that a little thought, just like I really had to when I first looked at it, because you learn all these rules about DR and BDR and how they get elected and what happens, etc., etc. Then you get to this network type, and Cisco says, "Oh yeah, there is no DR here," and you're like, "What? What? Why are we changing the rule here?" Well, by definition, on a point-to-point link, how many routers can we possibly have? We can only have two, one at each point of the point-to-point link. Okay. So far, so good. We're all on the same page there. We all know that. So why don't we have a designated router? Well, the real job of the designated router is to flood changes out that it hears about from other routers. It hears about a network change from one router, and then it floods that news out to other routers on the same segment. Well, here, if we only have two routers on a segment, which by definition is what we have on a point-to-point network, we don't need a designated router because there's no need to flood the change. Whether router 3 tells router 1 about a change, or router 1 tells router 3 about a change, everybody already knows about it. There's no need to flood the change on a point-to-point link because both endpoints are already going to know about it. So that's why you're not going to see a DR or a BDR or a DR other on a Cisco, on an OSPF point-to-point network. So again, this is, and it seems a little counterintuitive at first, but that is exactly what we expect to see when it comes to a point-to-point adjacency. That's what we want, is a state of full, and then you'll just see a dash right after that. So don't let that throw you. And also, I want to invite you out, if you will, to some free webinars that I'm holding. Of course, at the website now, we've got actually almost 300 free tutorials, videos, and practice exams. And you can also go straight to the CCNA webinars page. And if you like in Google, you can just do a search on CCNA webinars. We're right at the very top of those choices. We've got Frame Relay and Ether Channel webinars up now. We've got a lot more topics coming for both CCNP, CCNP certification candidates, also the voice, wireless, and security exams. So we've got a lot of great stuff coming up out there, and you don't need any money to go to these particular webinars. You don't need any extra equipment. You don't need a headset. You don't need a microphone. All you need is a pair of computer speakers and 45 minutes of your time and a desire to get certified. I want to thank you for taking a few minutes to watch this particular video. If you're on YouTube, please check the list to your right. We've got over actually 75 videos at this point, and a lot more to come. I'm Chris Bryant, CCIE number 12933, and I'll see you at the webinars.